Welcome to the Greenroom, a new podcast series by Sustainable Buildings Canada designed to help the building industry stay informed about the latest trends and techniques for building more sustainable buildings. I'm Jeff Fredericks, and I'm joined by Dr. Randy Van Staatren, President and Building Science Specialist at Building Enclosure Labs, and Josh Lewis, President, Energy Engineering at Nerva Energy Group Inc, based in Hamilton, Ontario. Today's episode will focus on the evolution of air tightness technology and its role in improving the overall energy performance of a building. We're going to talk about air tightness relative to new building code requirements, but also when the technology makes sense for existing buildings and the associated financial benefits. We'll also provide some tips and insights on best practices for how building professionals can approach air tightness solutions with their clients. So, let's get on with the show. Welcome, gentlemen. It's good to have you here. Why don't we start with you, Randy? Maybe you could tell us who you are and what you do.
Sure. So I'm Randy Van Staatren. I have a small firm in London, Ontario. We're basically a private research firm, which I would say also does lab testing and consulting. I would largely say the lab testing consulting somewhat subsidizes the research, but it also ensures that we walk around enough construction sites and crawl into enough crawl spaces and attics that we actually know what goes on in buildings, or try to. And so that's what we do.
Great. And what about you, Josh? Same question.
Yeah, so I'm Josh Lewis. I'm the VP of Energy Engineering at Nerva Energy, and I'm responsible for the overall engineering effort. Nerva itself, we're an engineering service provider deploying full building solutions to the marketplace, both with some in-house technologies, but we take on the scope of entire projects to make them efficient from a mechanical perspective, from an envelope perspective, and just really delivering holistic solutions for our clients.
Awesome. Well, today we're going to be talking about air tightness and its importance. And so let's start with a little context. We know that air tightness, of course, primarily focuses on the elimination of unintended gaps and cracks on the external envelope of the building. And it's also an essential part for creating a healthy and comfortable, energy-efficient building. But we also know that across Canada, many provincial building codes will soon require air tightness testing of large buildings prior to occupancy. So it seems certainly like a good idea to talk about the latest science and techniques. And so Randy, over to you. What do we know about the pending changes to the provincial building codes and the urgency for building professionals to address air tightness in their design?
Yeah, I may correct that a little bit. I don't think a lot of building codes are necessarily going to require it. I think what you're going to see, it'll be adopted into energy codes so that you can sort of claim some advantage for being more airtight. And that might be the most logical way and most cost-effective way to sort of hit your energy performance numbers. And so we're expecting to see an increase in demand. We've already seen it in Vancouver for much along those lines. But it's been more markets in the United States where it's been put in as a hard requirement, and sort of waiting for that to come to Canada, but I'm not sure when that's going to happen. There was a big battle in the last code update to make it a mandatory requirement, partly held back, to my knowledge, because of concern that there's not enough people that are probably capable of testing, particularly testing large buildings. But I would expect that to be overcome because we are seeing it in certain markets in the United States, Seattle, Washington, U.S. Army Corps of Engineers, having required it on buildings for quite some time now.
Well, we're going to get into the importance of testing in a bit, but as a follow-up question,
sure.
How far then have we come in the last few years when it comes to how we test and ultimately improve air tightness in large commercial buildings?
Yeah, so when you're talking about large buildings, we're just not testing that many, I think, to be honest. I'm sure Josh has experience in passive house projects. That's probably right now our forerunner where it's tested and it's a required test. Beyond that, it was very much along a demonstration sort of research level that there would be like the Ontario Associate of Architects, their headquarters would have been tested as a demonstration. I've done a number of projects like that, school boards or different large residential developer doing it as sort of a one-off basis. That's largely what we've seen to date. In terms of developing the techniques, the big thing is once you deal with monstrous buildings, particularly tall ones, we're a cold country, and so there's temperature differentials, and they actually drive airflow. And so testing a whole building technically, if it's quite large at one time, gets quite difficult or not impossible. So there's been a lot of development and techniques to sort of test part of a building at a time, both from a technical sort of experimental repeatability point of view, like accuracy point of view, but also like just logistics that you could finish part of a building, test it, finish another part of the building, test it, and keep working your way forward. And so that's already pretty well cemented out there. I think the ability to do that and the techniques are probably evolving at this point to be done more efficiently and cost effectively, and just gaining experience on how much equipment do I need to show up with, how much should I charge, typical consultant sort of challenges that go on. And then for the contractor, when should this be done? How complete does it really need to be done? How much prep work should we do? What's the cleanup involved? Should we hire a separate trade to do some of the prep work, or should we basically pay engineering rates for the young engineers to go out there and do prep work? I think there's a lot of maturity that'll still happen in Ontario, and stuff that I've seen from testing in Seattle, which is quite different in a more mature market, that I would expect to come here eventually, and probably our own flavor of it and slight differences.
Gotcha. Well, Josh, maybe this is a good time for you to talk a little bit about what your firm does in terms of, what perhaps even distinguishes it from other firms in the space, and then we can sort of follow up on the points you made, Randy.
Yeah, well, in terms of air tightness, so Nerva is the commercial deployer of the aero barrier technology across Canada for commercial buildings. So, traditionally, to get an airtight building, it had to be constructed airtight. So that meant that the tradespeople and the constructor ultimately had to do a really good job on site at every task. And I'm talking most trades. Electricians have an impact on that. The pipe fitters, the sheet metal workers, like the drywallers, everybody had kind of a piece of that. And there is a history of building airtight buildings using conventional construction methods, but it's a small history. It's proven to be costly, more suited for smaller projects. So some years back, to address this issue, technology was developed out of the U.S. called aero barrier, which now allows us to actually make buildings airtight through pressurize and spray. So it takes a lot of the construction variability out of the process to get a building airtight as you go, because the spray fills all the cracks and gaps that you can see and can't see from the inside out. So now you're no longer requiring every trade to tape, seal, and do a quality job on every penetration they make through the building envelope. So it's really kind of changed the game in terms of airtightness. I mean, to echo what Randy was saying earlier, in terms of required airtightness testing versus, just using it as a way to get to the energy codes, I think we're going to see a mix of both. But there's absolutely no doubt that even if it isn't mandatory, that people are going to have to start to do it. Airtightness for buildings is just good building science. It comes out of the passive house world, and it's one of the reasons that it's one of the fundamental foundations of passive house, because you cannot hit the other targets if the building is not airtight. The science is clear on that. So that's why they make it mandatory in that space. And because if we look at things like the Toronto Green Standard moving towards basically passive house levels of energy performance by 2028, airtightness is not going to be optional anymore.
Right. And so we're talking primarily of new builds, right? Let's shift the conversation, if we could, to existing buildings, because as we grapple with the daunting task of making our buildings more energy efficient, we know that there's a lot more existing buildings to tackle than worry about new buildings. Existing buildings, of course, present a big challenge. And Josh, I know you've got some experience in dealing with existing buildings, but maybe I'll start with you. Just explain to us, if you could, maybe what that big challenge is, and then we'll dive into some examples of how to maybe overcome it.
Yeah, well, I mean, with existing buildings, right? I mean, typically what we find is, the building envelope itself, the walls and the windows, the cladding are probably past their useful life just to begin with. And not only that, they were probably never airtight in the beginning, right? The market in terms of engineers, architects, and everybody involved in the building industry, air tightness is somewhat new to a lot of people. So we're having to kind of quickly build awareness across for that. I mean, when it comes to existing buildings, though, I mean, you make a good point. We have a retrofit challenge in this country, not a new construction challenge. New construction will come along, and we're going to be building great buildings going forward. But I think it's something like 80% of the buildings we're going to have to live with in 2050 are already built. So we do have to retrofit those envelope measures, including air tightness. Mechanical systems have to be replaced. Gas has to be eliminated, right? But when it comes to air tightness, we do need to start to look for innovative ways to make our existing buildings airtight, which, I'll pass it over to Randy, but, there's probably a couple different ways we can get to that, like overcladding with new systems, which also improves the insulative value of the building, and using, some more innovative technologies in order to get the rest of the holes out and get those buildings airtight.
Yeah, I think what I'm seeing right now, so I support a couple different sort of large weatherization contractors, they would be called, but they're basically retrofitters, or typically they go along with ESCO contracts, where sort of you're a municipality and the contractor will come in and they'll finance the upgrades. I'm sure you're involved in some of these projects as well. And so I get involved with the weatherization end of it and supporting some of those guys on trying to predict how much energy you're going to save air sealing. As much as we all think that like science is very settled, I think, varying estimates you see out there of how much energy you actually save when you air seal. The accepted approach is, yes, you definitely save energy. A lot of nuance to those calculations. That's kind of what I work with. But the folks that I'm seeing in the States, I'm sure the same people are in Canada. I just happen to have a lot of links down there. A lot of replacing gasketing on doors, sealing roof-to-wall interfaces, sealing around ductwork penetrations, doing that with spray foam or doing with tapes, or gasketing if it's a door and whatnot. And so that's going pretty strong right now in the U.S. and in Canada, I imagine as well. And I think that'll be a big part of different incentive programs that you'll see rolled out for commercial buildings, small and large, as the utilities are kind of reforming their incentive programs, particularly Enbridge here in Ontario. You already see some programming there, which I think we're going to talk about. But in the future, I'm expecting to see more air tightening stuff. And I am curious to see how aero barrier plays into it, as well as sort of more traditional approaches, which I admit's more my personal background. Yeah, there is a lot of emphasis on that. The other part of it, which I'm curious about, is we've had a lot of wildfire smoke. It used to be that people would be worried about building along the 401 or something and having local pollutants, or along a factory that might be releasing toluene or something, and having those pollutants come in. Now with wildfire smoke, I think not only climate change is kind of front and foremost for people, but also, do I live in a space that's really protected from smoke? And hopefully this issue isn't like an ongoing issue, but we really don't know. And so, the idea of better ventilation systems, ventilate right, airtight, ventilate right. I saw some of these filter banks in your little back shed back there. So better filtration. But also part of that equation is air sealing buildings. It's a lot easier to filter the air if the building is enclosed, if it has air conditioning is another part of it. That's a big challenge out west. They do quite a bit of work in Vancouver, so having to accept moving toward mechanical cooling where they hadn't previously seems like environmentally to go backwards, but considering it's getting hotter and they have to deal with smoke, that's a reality. And then if you're doing cooling and you're trying to deal with smoke, air tightness goes along with it. So that's a really interesting perspective that I'm curious to see how that kind of moves forward and potentially gets codified or gets worked into different CSA standards aimed at building more climate resilience for the kind of challenges we're going to have in the future.
Well, that's a great point. And there's a lot of things that employers are now dealing with in a post-COVID world. Figuring out the return to the office space is one of the challenges in these hybrid models, 3 days a week. But certainly, if the wildfire example that you use, you're not going to get a lot of people raising their hand and going, "Yeah, I'm happy to come into the office if the air quality within that environment is not up to snuff. So these are good points, and maybe they'll drive further action. Josh, I want to pick up on something you shared with me before, just in terms of the barriers of getting some of this work done, and cost being one of them, right? When it comes to existing buildings, I think you shared with me in the past that often you kind of have to look for the ideal project where maybe you're stripping everything down to the studs anyway, and that's the time to go and make that kind of investment. And yet, Randy, you brought up a few things that can be done to mitigate air loss or improve air tightness through sealants and around the door and so on and so forth. So I guess my question is just like, is there an ideal candidate for an existing building on when you're going to get a real solid job done?
That's a good question. So let's start from like maybe the obvious candidate, which I think is what you're referring to. So like we are applying aero barrier to a deep retrofit of a relatively short office tower in downtown Toronto. So it's an older building. The owner is stripping it to the walls, complete new mechanical system. And the case for air tightness there was simple. They're trying to get the most efficient building possible, but actually the cost to air seal the building, they're saving on the new mechanical system. So their engineers bought off on downsizing the new heating cooling system because it's going to be air sealed. And so it was actually a cost positive thing for them from a capital perspective, and will produce a better building ongoing, right? Now, I mean, that's a traditional office building. Those can be evacuated, those can be, retrofitted. They don't have a lot of the mechanical penetrations and operable windows that you see in other types of buildings, like multi-res buildings. So multi-res buildings are a whole other story, right? You've got a lot more places for air to leak, operable windows, balcony doors, mechanical penetrations. That is, I don't know if we figured out a solution for that one yet, because that one, there's a lot of the stuff you can do around the periphery, which Randy referred to, replacing seals and those types of things, maybe new windows if they're obsolete. But ultimately, your ability to deep retrofit those buildings is stymied by the fact that people live in them. And we're already in a housing problem, so we don't have any other place for those people to go, right? Whether it's an apartment or a condo, it doesn't really matter. So I think the whole retrofitting air tightness beyond some of the simple measures can get pretty deep and can be pretty disruptive to a space. And there's other things that we need to do in those buildings as well. And I don't know if we've come out with the perfect solution, but we are starting to see innovation in the space. And we're not involved in in this project, but the Windsor-Essex Community Housing is doing a project right now where they're recladding an existing apartment building while the tenants are in it. And they're also improving the mechanical system for greater efficiency at the same time. However, that is requiring them to lose one apartment per floor to put the new mechanical in. But when that project is delivered, I think it'll be the first like that in North America, as far as I'm aware, that they're really going to that level. So they've already built new passive house, and now they're doing this in-person retrofit where they're not kicking the people out of the building. I mean, we could also look at, for example, at the 500 McNabb project here in Hamilton, which was a complete retrofit of a 60-year-old apartment building to passive house, but that required the building to be emptied. So
all at once, though. They didn't do it in sections. The whole building.
Whole building was emptied. Building was emptied. Balconies were stripped off. The entire building was reclad. That building is now airtight due to all the measures they put in. But that's pretty disruptive.
Sure.
Right.
And how long did that take?
We weren't involved with the project, but I mean, the building had to be empty for at least 2 years.
Yeah.
Yeah, I would also say, that's an example of a project where they really went to town and impressive what they did, but. Large budget. But in terms of like vacancy, spaces like the one that we're in do come vacant every 10, 20 year on lease overturns and growing businesses and moving businesses and whatnot. So on a commercial end, there is quite a bit of move in and move out of spaces. Most of them are owned by an owner and they have a tenant, and tenants kind of come and go and move around. If you're dealing with the larger office towers, you'll never get the whole thing empty. And so inevitably you're doing like component level air sealing, or it's going along, as you said, with a window replacement. And you kind of lose that opportunity to maybe optimize mechanical advantages through air sealing and whatnot. In a space like this, for instance, if you do a whole bunch of insulation work and you air seal it and reduce heat loss significantly, they're probably replacing the mechanical rooftop units with the exact same size. Right. Like just because no one looks at it, it's not worth, or they typically don't hire an engineer to go and resize them. You just read off the nameplate, you put one on the same size. And in some cases, the savings also aren't that substantial. Like a difference in a ton of a rooftop unit might be only $500 or $1,000. So that doesn't even pay for the engineering to go and check on it. So they're definitely a different animal and has to be much more cost efficient. Potentially aero barrier when you have like tenant changeouts. And especially if they're doing some major gutting, removing systems, furniture, and finishes, they're all getting turned over, which environmentally you've got other issues there for sure. Hopefully, they're getting recycled, hopefully they're salvaged. There's probably opportunities there to do it in a very cost-effective method. But otherwise, otherwise there's local air sealing. The part that gets me with local air sealing, and not to pick on my friends in the States, but often, you're going around a building and basically, there's a roof to wall interface, so it must be air leaky. I see, they sort of pick their winners of different penetrations, and there's not a whole lot of verification that you're sealing something that's actually leaky in the first place.
Right.
Now, chance and probability would say that if you sealed them all, on average, you must be hitting some sort of hole. But you run into a number of complications where you might seal a roof-to-wall interface on the inside of a building, but really then the air just finds another path to electrical outlets, or an unsealed base of the drywall. And so, I'm a researcher at heart, bit of an academic, so I see a real lack there of research. I'm not saying we shouldn't do it, but I think better quantification of it and the technologies would be of great value. And I try to push that onto my private clients, but it's very difficult for them to sort of put up the money for it. So there are people like U of T, Marianne Touchy, and folks who are working on those things, I think. I think that's another challenge right now, because as an owner, if you sort of push back on it, it's hard to it's sometimes hard to justify the expenditures, especially if there's a little bit of uncertainty.
Well, even to use the analogy of a homeowner with a residential property, where what you're describing almost sounds like a bit of patchwork, right? Like I know there's some cracks, and maybe I'm going around with my putty knife and I'm just sort of patching them up and hoping that I've captured all the cracks, but it's a bit of guesswork. And so what you're describing is a need to actually test and actually validate that the work's being done properly.
Yeah, so I'll be doing a couple, but using like diagnostic tools to do that kind of work, which are getting pretty and theatrical fog machine or IR
smoke
camera.
pens.
Now IRC did a presentation on using acoustics, which I'm very curious about. That where there is a leak, they used to do this in compressed gas. I think you would walk around with like soapy water initially and see where it bubbles, and now they kind of walk along with kind of like some fancy oscilloscope. I'm not describing it well, I haven't tried it yet. Probably someday I'll drop some money and buy a kit or see what other people are doing. But there's different technologies coming along there, and some more and less invasive. I went into a clinic and we kind of cleared out part of it and we fogged it. But explaining to people still sitting in their office, there might be the smoke coming into your office, and making jokes about, hey, this is the same stuff they use to film Thriller, and get up and do a little dance. It's perfectly healthy, this kind of stuff. It's still a little unnerving, and it's you can't do that in a space full of people visiting the clinic, and there's still some room for advancement there. But basically, finding the holes and plugging them is one part of it for occupied spaces, about how we can get some mileage there if we're specifically focused on air tightness. And I think the other part of it is, I may not have given it justice when I was talking about, there's not a lot of money savings for reducing your mechanical system slightly. I do have clients that have a vision of their property getting electrified, and when they go through that decarbonization, maybe the air conditioning that's already part of their mechanical plant has enough electrical running to it that's enough to also supply the heat pumps to heat the spaces. But if they do have to upgrade their electrical supplies, that's a major cost. So while you're operating a building, as you're doing improvements, to be chugging down that heat load, in the future, it's definitely going to save you money. And especially if, for whatever reason, you're going to electrify, most likely will save you some serious money.
Right.
But those two things are often, displaced in time. And so it's hard to necessarily take money from one and know that it's going to save you in the future, as opposed to more direct savings where your energy bills are going down so much so you can have a 5-year payback period or whatever. And so that's often a complicated sell.
Is it then necessary that we do a bit of a mind shift on how we look at these assets? So for the building owner operator, I'm thinking from their perspective, because as you say, sometimes it's more black and white. I'm doing this. I'm not worried about the future, because that's potentially somebody else's problem.
Well, no, that's a very good point. I mean, what Randy brings up there, we have to get more use as an industry of thinking about life cycle costing, right? And this is whether it's new construction or retrofit, right? I mean, when I talk about mechanical systems, one of the first things that I say is, by the way, you should spend as much money as reasonably possible in the building envelope before you even start thinking about sizing and choosing the mechanical systems. Because ultimately the mechanical systems may have a life of 20, 25, 30 years kind of max. They're going to come due for replacement before the building envelope is, right? So and ultimately the most efficient use of energy is to not use it at all. So you can have a super efficient mechanical system, but by putting as much money into the walls, windows, air tightness, and the other parameters of the building envelope, you simply just don't need to use the energy, and you end up saving money on the mechanical system. So this is where that dichotomy has to arise, but that's a complicated conversation to have, right? Yeah. So it has to, we have to get better as an industry of talking around that way, and then looking at that over 20, 25, 30 year life cycle costing. But that's, we're so short-term focused. It's just like the stock market, right? Quarterly profits, you know. So we're a long ways away in most cases from being able to have that extended discussion.
So what is the pitch? Because ultimately the folks that are going to be viewing this podcast, they're building professionals. They're needing to kind of work this equation into their pitch with their clients. Like, how do you get around that idea that yes, we need to get the industry thinking more long term? And I've started to read, for example, that investors are now demanding that they see, an effort on these assets. Otherwise, they depreciate them, right? Like it's like you just lost a lot of value.
Brown discount. So brown discount. So we've talked a lot in previous years of is there really truly a green premium for buildings, right? Like, well, is a green condominium going to sell for more? Can you lease out a green office space for more money? History suggests that yes, there is some of that. Maybe is not as much in the greater Toronto market as some other markets in North America that actually do have a significant difference there that can make that up. But now, we're starting to flip onto the other side, and it's the brown discount, because looking, even financial people realize that buildings that are going to have high greenhouse gas emissions are going to get more costly to operate. And ultimately there is going to have to be some money invested in those to partially or fully decarbonize them or electrify them. So yes, there is movement in the market now to start to discount the asset values and going forward. So that spurs on hopefully more investment to upgrade those buildings and get them back to where they're not a drag on somebody's portfolio.
I think it's an interesting one. I can think of, you remember back in the day, you would look at a new house, you'd look at buying an older house, and did they replace the windows? Which is funny now, because you might buy a house with replacement vinyl windows that are up for replacement again because they did it so long ago. Or the other one would be, have they replaced their oil furnace with natural gas, because the oil became so much more expensive than natural gas. And so, I think I'm a bit of a realist. It's a little bit hard to predict in 10 years whether or not there'll be a clear differentiation in the market. Hey, when was this condo built that I'm investing in? Was it built before or after NECB 2020 came in? Right. That, to me as a building scientist, I could see a major differentiator there. For the occupants, it's a little bit unpredictable. I've definitely had conversations with condo developers and apartment building builders about this. Around the time of COVID, actually, are we going to, post-COVID, want to maintain higher humidity levels in our buildings? If we want to do that, you're more at risk of condensation problems on cold surfaces, condensation in walls with air leakage. Is there going to be a major differentiator between buildings that looked after air tightness and thermal bridging and decent windows and ones that didn't? The building scientist in me is like, oh yeah, people are totally going to get this. Right. But the realist in me is it's uncertain if there'll be that or some other more functional changes about Amazon deliveries or drone delivery someday, or I don't know. It's somewhat unpredictable. What'll really change the market? We do have a history of energy stuff, like I described, and definitely right now, insulated, not insulated buildings, I think does drive owners to make certain decisions. Like insulation, typically, when you have an existing building, it's a tough payback period. But if you're spending a ton of money in a building, well, you're silly not to upgrade it to modern performance. So I definitely see a lot of building developers insulating even if they don't legally have to, because they're worried about this perception of it not being a modern building, essentially having modern comfort or something like that, even though there's really a lot of nuance to that.
Yeah, for sure. And when you look at commercial real estate or companies that have a broad portfolio, they've also made these public statements on their ESG targets, and so there's pressure there to kind of deliver on them, both those interim targets and the long 2050 targets, right? Yeah. So you're hearing more and more people talk about the need to be accountable for those things. And then of course there's all the carbon tax stuff that people know is coming down the pike. And so are we doing enough to mitigate against that financial impact that's coming, right?
Well, the carbon tax is driving a lot of this discussion, and I mean, it was intended to, because the carbon tax is the market-oriented solution to making greenhouse gas emissions unaffordable. So, whether it's for buildings or transportation or industrial processes. So, it's having that effect. I mean, obviously we have regulations driving the building market as well, like the BC Step Code and the Toronto Green Standard. So we kind of got a mix of both, but the carbon tax is kind of the catch-all. Now, the carbon tax right now is forecasted, or at least public, to cap out at 2030 at $170 a ton. But no one realistically expects it to stay there. And economists have said that it has to get somewhere to $300 to $500 a ton to truly have the impact it needs to have for us to meet our climate goals by 2040, 2050 as a country.
Yeah,
so
definitely with I do some teaching, and I walk through with my classes like what the impact of natural gas prices are going to be on carbon tax. And if you look at expected inflation of electricity costs, and it's hard to predict how much of the upgrades to our electrical infrastructure is going to be paid through premiums and how much of it's going to be paid alternatively, maybe through direct government funding or whatnot. But it's not enough that I think it's going to drive massive changes, especially we're living in an era of high inflation. Natural gas prices are more affected by the war in Ukraine than by carbon tax. So there's a lot of bluster over carbon tax right now. But as you're saying, it's not at it's at a scale to make us think about it, but it's not at a scale to make massive change. Right. You could also argue the other side. That's also not of a scale to drive people into poverty that are already living in crappy, uninsulated buildings that have their utility costs a major portion of their household spending, or make greenhouse vegetables unaffordable in Ontario. Right. These sort of things. These things take time. So there's a bunch of nuance, I think, to that discussion. The other one, you've kind of hinted at and want to discuss ESGs. And it's very interesting as well. That's a complicated beast. I get a subscription to The Economist, and so they're all over the map on it, know. And I used to work as a lead consultant back in the day, and kind of sustainability consulting, and I see pros and cons there in terms of driving things, and also you know, when you work in the industry, there's a certain amount of greenwashing. That's marketing's part of it for sure. And how much of it is just pure marketing, and how much of it's really making opportunities for change or driving change. And so, you know, the influence that'll have on the market is interesting. It's definitely having a big influence on, if you're a university grad and you want to get a job in sustainability consulting, it's having a big influence there for sure. Like that market of people with expertise here. Hopefully it translates into you know, more mechanical engineers having backgrounds appropriately fitting, and more of those solutions being more economical. But I hold my breath on it, I suppose, a little bit. Yeah.
But you know, maybe more specific to air tightness in the local market. So like, you know, the Toronto Green Standard moved ahead another tier in May, right, as in April-May, as it does, and it's on that path. And we're already starting to see now for buildings going for site plan approval, you know, there's kind of two major things that are happening. They're starting to remove balconies, because those have traditionally been thermal bridges that have severely impacted the building performance, right? Like almost every balcony you see on a building is literally a radiator fin, but most people don't realize that, right? That they're directly connected to the floor slab. But the other thing they're doing is they're switching to ground source heat pump systems through some innovative programs that certain companies are offering to the market, where that system is paid for by the condo over several years. So those two measures are helping them get there. But you know, I participate in enough building design reviews to see that the impact of moving from double to triple pane windows is not typically huge on the whole building performance. The impact of doubling the wall thickness can be a few percentage points sometimes. It's not necessarily huge unless it's done in a more passive house way, but you start to look at the impact of air tightness on some of these building energy simulation models, and it can be 10%, 20%, or even more in terms of total performance. So, you know, I think the industry is starting to realize that there's more of a clear path here for what's the next thing we have to do to improve the performance of our buildings. You know, air tightness alone is not going to carry us fully to passive house levels by 2028 in Toronto, but it's going to be a key part of getting there before we start to do some of the more harder things that the industry is going to struggle with.
Yeah.
I think there's two directions here. So one is through regulation, which we've seen even in the air tightness, very specific performance measure. And there's definitely been done, you know, and been done a long time ago and shown to be quite effective. Like in Seattle, they have tracked as they've tightened up the standard and imposed a mandatory air tightness. When I say mandatory, there's basically, you can pay your way around it, but it's enough that most of the market is falling into shape with it. And that's been quite effective. And then the other approach is just that people recognize value. You know, people pay a lot of money for very fancy coolers that are basically more thermal efficient than the old, like a lot of money. It shocks me when a buddy shows up with a Yeti cooler, right? But you know, good for him, and it works. You know, you know, people are willing to pay money for stuff that they can perceive an advantage of. And if you look at, you know, electric cars be another similar one, right? Like, if you ban gasoline cars, people are going to drive electric, but people are going to drive electric cars in Georgia. Even though there's not, I'm not a Georgia expert, but I assume there's no ban coming or in sight or whatever. And you know, ideally, we do find solutions where the advantages are compelling enough that they also drive people. But inevitably, we're going to have stuff that has some nuance to it. You know, we're all kind of preaching to the choir here about air tightness, energy efficiency stuff. There's still, like, you know, maybe more at the homeowner level or building owner level of people that, you know, still question, well, you don't want it too airtight because it's got to breathe sort of stuff, and that's long dead if you're kind of, you know, even the average architect at this point, or definitely anybody in our field for sure. But when you have some things that have nuances like that, where people are worried, have anxiety about some aspects of it, like regulation is part of moving it forward. And a bit uncertain how air tightness will play in that, but the evidence from the States, I'm just surprised it hasn't been adopted more quickly, to be honest. I think in Canada, some reluctance about, well, I deal with some big buildings or staged hospitals and things like that. What, is this going to be some sort of massive construction challenge to do the verification of it through air tightness testing? And we have mature markets where they build hospitals and test them, or they build large buildings and test them, and have kind of shown that that's just another cost like anything else, testing out the fire alarms or doing other activities, that it's doable. But we'll see.
Yeah. Well, and I did want to just talk about testing, because I know that's something you do, Randy. You help teach people, I guess, right? How to test. You hold workshops and these sorts of things on that. Is that true?
So Enbridge Natural Gas, they run programs to try to encourage energy efficiency, of course. And utility programs across North America have been very effective at encouraging energy efficiency programs, either through natural gas utilities or electrical utilities. If anything, they're probably the biggest promoter, like at a regular person level, not necessarily the showcase passive house project or the fanciest building out there. And so Enbridge released a program previously to subsidize air tightness testing of whole buildings. And to kind of encourage uptake of that program, they also have been offering free testing, and sort of where you could show up in a lab setting and actually run a couple units at the same time, ask all the questions you might have about what sort of temporary air sealing you do, what specifications might look like if this is working into a real construction project. And so we share that through workshops. We did 2 this summer through they were done at Earth Rangers, but through SBC, funded by Enbridge. And so, we'll see about commitments for next year and stuff. So I don't have a lot to give there without knowing for sure.
But it's a big part of the journey, of course, is to get more people familiar with the testing piece of it, of course, right?
Well, I would say right now, the demand's lacking, not the testing ability.
Okay.
Here in Ontario, you probably do have like maybe 10 firms that would be capable of doing a fair size building. A big monster, maybe only really a handful. But there's not a ton of it going on yet until the demand's there, either through regulation or through, as I said, that value being translated into buildings.
Gotcha.
And testing alone isn't what solves all the problems either, right? It's got to be, it's the air tightness. Now, some level of policing or shaming through testing, that's the feedback I've gotten from Seattle. It turned out we just need to start testing buildings, and they saw basically the numbers slowly drop over time, because as you test it, inevitably you walk around and you point out where all the faults are, and there's sort of that growing education amongst the contractors where, they're all quite proud of their work. And so when you do have an air leak and something was inefficiently installed, the intent is that they be airtight. So they're also looking for those improvements.
Okay.
So there's some nuance to that angle of it, I suppose. But
Yeah, so we've used that Enbridge program for air tightness testing with some of our partners and Collective, a mid-sized developer in Toronto. So Collective stepped up to the plate in a year or so ago, and they committed to doing Canada's first multi-res airtight building, which they did with us and the aerobarrier technology. So 16 stories, 177 suites, and we sealed each suite to be an airtight box. So we're not just talking about the building envelope wall, we're actually talking about the demising walls, the floor, and the ceiling. And ultimately, it's hard to translate the performance of airtight suites to whole building models, because actually the modeling software is somewhat behind in that regard. The way we do energy modeling now and really air tightness performance, we're looking at the building envelope air tightness, not necessarily whole suites when we're talking about multi-res. But I think anybody could agree, though, if I'm going to live in a multi-res building, wouldn't I like to live in an airtight box so that I'm not sharing any air with my neighbors, all right? Not from the hallways, not through the walls. And as Randy mentioned earlier, that can also have some acoustical benefits as well. Airtight boxes tend to have better acoustics. But overall, we learned some things through testing that building. The whole building test was actually relatively easy to do. Done in a day, came out great. We had a target of 1.31. liters per second meter squared compared to a Toronto Green Standard suggested target of 2.0. But that's not enforced right now, or at least wasn't. There's no enforcement mechanism for that. But so we beat the target significantly. That is going to be an efficient building. But we did some other testing. We didn't just do the whole building. We did some guarded floor testing. We also did some suite level testing, and not all the data was good when collected. The guarded floor testing specifically. The data was kind of all over the place, and we in the end, when we got the whole building test, we started to look back and realize that maybe guarded floor testing just wasn't going to be that practical from a repeatability point of view. So for future projects now, we're looking at doing more guarded suite testing, because what we're trying to get with that guarded testing is truly understand the existing and then improved air tightness of the outer wall. Because that's what goes through the whole building test. It's the outer wall, everything that's part of the outer wall, the wall, the windows, and the mechanical penetrations that go through that wall. The whole suite air tightness is a totally different parameter that may have some relationship to whole building performance, but that actually is still further research in the industry, right? Because whole suite air tightness and multi-res should prevent a lot of stack effect from coming up in the building. It would allow less air to come up, but the industry in terms of the mathematical modeling and the software hasn't even caught up to that yet. So there's still a lot to learn. This is still an active area of research, certainly. For large building air tightness, but nobody doubts the benefits. I don't think it's simply a matter of quantifying those benefits a little bit better in all aspects, so that we can make it just standard part of the discussion going forward.
Right. Guys, I've got one last question for both of you. This has been a great discussion on air tightness, of course, but when we think about being in the industry that you're in, the building professional industry, what is it about working in the space today that excites you the most? I mean, you're talking about stuff that's changing rapidly. You're both on the forefront of a lot of the new technology, seeing how it's being implemented in different places like Seattle. But what is it about working in this space today that excites you the most?
Well,
Randy?
Sure. I would say it's probably evolving more rapidly than it has in the past. I think the construction industry has been a lot of tradition of how you do things, a lot of black art on how you do them and why you do them, and maybe for good reason. If you do something and it works and you repeat it, you typically do a good job repeating it. Typically, it works similar to how it worked in the past. And that kind of model has served us well for a long time. And we even did a lot of things that I don't think we really understood why they worked or whatnot. They just became tradition. And so that's really changed in the last, quite a while ago. Last 20, 30 years, it's been evolving fairly rapidly to really be more science-based, where why you do things, understanding functionally why they're working that way. And when looking through it in a different lens, it's managed to have things evolve, see a lot of new materials introduced. That excites me. And also just the conflicting challenges we have with environmentalism. We want things to last a long time. We want to build them out of natural materials. We want them to be low energy. We want good indoor air quality. Often all those things align, but not all the time. And so, myself, I get super excited about when they don't align and how you balance one thing over another or seek sort of a win-win solution, ideally. But the reality is sometimes you do have to make trade-offs, or the trade-offs regarding socially. Some things cost money to be done in a certain way. That money could be spent elsewhere. How do you make the choice when to spend more money on your building or spend more money on function? Buildings are by far the largest assets that we own. We've invested a lot of money into our existing building stock. We're very focused on Canada's debt, say, but really, we have a lot of money invested in buildings. And so, should those buildings be durable? Should they be more flexible to be torn down when there's a bigger need for the space, higher density? how we balance those things out. Do we just leave it up to the markets? Do we try to have some overall guidance to it? Yeah, a lot of it exciting things, and especially in Ontario where there's a massive boom currently going on. The construction industry is busy. Here in Hamilton, bonanza sort of going on in construction work, which I don't see slowing down anytime soon. So yeah, that combination of things is very interesting to be in this business at this time.
And as you mentioned, rapidly changing, the climate change mitigation component is a big piece. The wildfires that you mentioned now part of the conversation in some of this change. So Josh, what about you? What is it about operating in this space today that excites you the most, and you know, what you see sort of coming down the pike?
Yeah, I mean, it's definitely a great time to be in the energy and you know, carbon mitigation field. You know, there's a whole lot of different roles within that. You know, sustainability consultants, engineers, architects, but really like the whole value chain has to go. I mean, I certainly will echo Randy's comments about the fast evolving pace, and you know what, with good reason. I mean anybody who's saying we're not in a climate emergency right now isn't really looking at the data. This summer we've had record high ocean temperatures, record high air temperatures, and record high Antarctic ice melt. So there's no question that the climate is changing. Our buildings need to be adaptable. Our buildings also need to be resilient. One thing that we didn't even mention about airtight buildings is airtight buildings retain their heat much longer. So if you have a utility outage or something like that, an airtight building can remain habitable for days compared to hours, compared to a conventional building. I mean there are so many other advantages, and as the weather and the climate gets more unpredictable, you know, those will be advantages to the ecosystem. But like me personally, like, you know, it's been a journey through energy efficiency really since 2010. I actually started my career in the automotive industry, but around 2010 is, you know, that's when the Save on Energy programs rolled out here in Ontario, and that was the first time we had a comprehensive province-wide electricity energy efficiency program. Enbridge was certainly doing some stuff before that, but we didn't really have anything on the electricity side. So really, as a province, we've been on that journey since 2010 to really push energy efficiency into all sectors and all things. And back in 2010, I was working more on the industrial side, and certainly a lot of potential there. There's no doubt. But buildings are like a mass market, right? And industries tend to be very process driven, very specific, kind of unique solutions in a lot of cases, whereas buildings are kind of ubiquitous everywhere, right? So there's just so many, there's so much potential. That's what gets me out of bed in the morning. There's so much potential impact to have at a building scale, at a portfolio scale, and ultimately at a provincial and a national scale to just deploy intelligent solutions. Like, you know, I'll just throw one out there. Like, for example, you know, our typical rooftop units on buildings, like this building is heated and cooled with just typical gas-fired, electrically cooled rooftop units, right? You see them everywhere. There's you know, hundreds of thousands of those things. And, you know, there's already really a great solution to help move us forward, which is when one of those units needs to be replaced, because they typically only have about a 20-year life, maybe a little longer. You know, the availability of heat pump rooftop units with gas backup is really not much of a costly option these days. So essentially, you can on even a cheap unit like that, you can run no carbon heating, no gas heating, from, say, you know, 18 degrees Celsius down to about -5 degrees Celsius. At that point, the heat pump won't do anything for you anymore, so it's got to switch to gas. But if you even consider the impact of, you know, from 18 to -5, that's a lot of hours in the year. That now no longer, that can easily take 30, 40, 50% of your gas usage out of a building with just simple strategies like that. Yet we're still not universally doing that, right? But we are starting to see movement, especially on the single family home side. You know, these new incentives now for heat pumps instead of furnaces in houses. You know, so we are starting to have those conversations, and there's so many of those conversations to have and to get the entire industry on board. and then make the progress, get the innovators innovating, and then it's just going to be mass market adoption. So there's a lot of work to do, and there's not a lot of time to do it.
Right.
So let's sharpen our pencils and get to work.
Nice. Well, on that note, thank you both for joining me today. It's been a great conversation, and hopefully this will spark more interest and conversation on this very important topic. So thanks, guys.
Great.
Thank you.